Hello again, everyone. Today's video is going to be about expressions. So we're going to talk about simplifying expressions. We're going to evaluate expressions. Everything in today's video is going to be all about those expressions. So always remember to use your order of operations when you're doing anything with the expressions. So if we look at our first example here, where we are asked to simplify according to our order of operations, and we can remind ourselves what that is over to the side. In case we forgot, not sure how, but it happens, I guess. We have our parentheses, we have our exponents, multiplication and division in order from left to right. Same idea, addition and subtraction in order from left to right. So if we're looking at our first example here, when we're talking about parentheses, we're talking about simplifying something inside the parentheses. But 2 minus 3x, those are not like terms, so there's nothing that we can do there. I also don't see any exponents in that equation, expression, which means we're down to multiplication and division. Even though I don't explicitly see a multiplication sign, I do know that a number right next to a parenthesis shows us that we have to use multiplication or a distributive property. So let's go ahead and distribute as our first step here. Now, this is a 3, but we have to take the sign along with it. So I'm going to be distributing -3 to both terms in the parenthesis, which means when I simplify, I'm going to bring down the 6x. -3 times 2 will give us -6. -3 times -3x will give us a positive 9x. From here, if we're kind of going down our checklist, right, parentheses we couldn't do, exponents didn't exist, we took care of our multiplication and division. Now we're on to addition and subtraction. We'll do that in order from left to right, again, just combining our like terms. The only like terms that we see here are going to be the terms with the x's, the variables. So if we combine those together, we're going to end up with 15x and then minus 6. We'll just carry that down. It has no like term. And that, my friends, is our simplified expression right there. 15x minus 6. Notice I also wrote my answer in standard form. I put the variable first and then the constant term second. So let's always get into the habit of doing that, please. If we look down to our second example, it looks a little confusing, right? We got two variables here. We got x's, we got y's, we got exponents, right? So if we're looking for like terms, I'm seeing first that I have an x squared y here, and I have an x squared y here. Okay? So those are going to be like terms. So x squared y minus x squared y, well, they just canceled each other out, so they go away. Now, of the two terms that are left, who thinks out there that those are going to be like terms? They kind of look different, right? It's a x to the first power and a y to the second power in this first part of the expression here. And then in the second term here, it is still an x to the first power and a y to the second power. The order is different, but it's still the same terms are still raised to the same power. So they are actually like terms. So if we add this, and you can put a little 1 in front of there if you would like. If we add 1xy squared to 2xy squared, we end up with 3xy squared. And some of you might be asking, well, can I put 3y squared x? You can, but again, kind of like the first problem, when we want to get into the habit of writing stuff in standard form, when we have more than one variable, you want to try to write them in alphabetical order. So this would be the most appropriate answer for the simplified expression. All right, next problem down. This one's kind of big, so if you want to pause the video right here, see what you can do to try to simplify it, and then we can come back together whenever you're ready. Go ahead, hit play, and we can go through it together. All right, so to start doing this problem here, I'm going to just go through all my distributive parts. So I don't have anything inside the parentheses that I can go ahead and simplify. So that's why I'm just jumping down. And there's no exponents, so I'm just jumping down to the distributive part. So it's 2ab minus 3ac. I'm going to distribute into my next part. I'll just change the colors so that you guys can see the different pieces that I have. If I distribute the 3c here, I get 3ac. Just again, getting into those habits, I'm putting everything in alphabetical order. 6bc. and then plus 9c squared. Hope I don't run out of room. Let's see. Let's do purple. If we distribute here, because again, we have a negative, so just be super careful with your signs, please. Minus 2ab plus 2b squared plus 6. Oh no, I'm not going to quite fit it. b, c. That didn't quite fit. Almost. Now we have this long stream of terms, and now we got to figure out, well, are there any that are alike, anything that we can combine? So I'm just going to go in order. For a's, I don't see anything other than that a squared in there. I don't see it combining with anything else. So I'll have an a squared, and I can kind of cross it off as I go through. So use yellow. Just cross it off, that way I know that it's done. Anything else with an a, I see an a term. For sure, I see an AB here, and I see AB here. So positive 2AB minus 2AB are actually going to cancel each other out. So that one's good as well. I see ACs. I have an AC here and an AC here. And again, positive 3 and a negative 3. Those end up canceling each other out. All right. I don't see anything else with A's, so let's move over to B's. I do see a B squared. 2b squared. So I'll add that into my answer here, plus 2b squared. With b's, I have a minus 6bc and a positive 6bc. So again, those are going to cancel. And the only other term I see left is this 9c squared. So plus 9c squared. So even though this was a kind of a scary looking problem, there's so many terms, a lot of it actually canceled out, leaving us with just a squared plus 2b squared plus 9c squared. All right, so there goes simplifying expressions. The next part of expressions that I wanted to go over is our double distributive property. So our double distributive property, some people also call it FOIL. FOIL is the acronym that we have, the method for simplifying there. So for this problem here, we're going to be foiling when we have a binomial, two terms, inside one parenthesis that's being multiplied by a second binomial inside a second set of parentheses. So if we have just a regular x, say, that's being multiplied by x minus 5, well, that's very much like our last example. We distribute and we're done. But we're going to do the same idea here. We just actually have to do the process twice, because we have to distribute that red x that you see to both the x and the minus 5. And then again, we have to distribute the 2, the second term in that first parenthesis, into, again, both terms of the second parenthesis, the x and the minus 5. So I'll show you two different ways of doing it, and you guys can kind of decide which method that you like to use. So FOIL method, I'm going to try to stay with my color choices here. I colored the x red. So I'm going to distribute the x to the x. X times x is x squared. X times negative 5 is negative 5x. So that's our first set of distribution done. Second set, now we got to distribute that 2. So keeping the sign in mind, it's a positive 2. 2 times x is 2x. 2 times negative 5 is negative 10. Okay, we do have some like terms here. Always got to look for those to make sure that we have a completely simplified answer. We have our middle two terms that are going to simplify. So final answer there will be x squared minus 3x minus 10. All right, so that's the easiest way of solving the problem. Some people tend to forget terms, or they might forget in larger problems, like, did I multiply that one sugar? Did I forget that one? I can't remember. So a nice kind of visual way of doing it is to set up a tic-tac-toe board. So all my visual learners out there, you might appreciate this. If we set up a tic-tac-toe board, we're going to put the first parenthesis across the top. So I have an x term and I have a positive 2 term. The second parenthesis I'm going to put down the side. So again, I have an x term and I have a minus 5 term. Okay, so this is more of an array example. It's called where you're going to now multiply every row by every column. So again, same idea. So x times x is going to give us x squared. If we go across, x times 2 is going to give us 2x. And I like putting this in there too, just so that we remember. And now let's go down to the next row. So negative 5 times x is negative 5x. Oops, sorry, that was a little sloppy. And then negative 5 times 2 is negative 10. So again, when we're looking for those like terms, we're just going to be looking actually across the diagonal here. These are always going to be our like terms. So same idea, we can go ahead and we can combine our like terms. We still get x squared minus 3x minus 10. So same answer that we had gotten using the prior method, right? We got this time. It's just two different ways of looking at it. Yeah, it's kind of an extra step to do it the second way, but if you have the tendency to forget terms, this second method is a lot easier, less likely for you to forget a term. So again, if you want to pause the video, see if you can try these two, right? This one's very similar to the one we just did. This one's a little bit longer, so you might want to try that second method. So go ahead, hit pause, try, and when you are ready, you can go ahead and hit play. All right, first example, I'm going to go across. I'm going to do my little rainbow here. So I have 2x times x is 2x squared. 2x times 3 is 6x. Going down to my second term now. Negative 7 times x is negative 7x. Negative 7 times 3 is negative 21. When I combine my like terms, I end up with 2x squared minus x minus 21. For those that want to put the 1 in front of the x, you can, but you also might recall from Algebra 1 that that is not necessary. All right, let me put a little break in here so that I can go ahead and look at this second problem now. So I'm going to be distributing everything. So when I do my rainbow this time, I'm actually going to do it backwards. So I'm just because there's two terms in the second parenthesis, I find it a little bit easier and less steps, right? Everyone likes less steps. So I'm going to distribute the x to everything. So in that case, I get x cubed plus x squared plus 7x. Now I'm going to distribute my negative 2. So negative 2, again, distributing that to everything that's in here. And also note that when I write my answers this time, I'm going to put the like terms underneath each other. It just helps when you're going to simplify in that next step. You don't have a long string of numbers that you're trying to search around and find something that's like it. So we'll just kind of go through that organization right now. So negative 2 times x squared is negative 2x squared. I'm putting it underneath the other x squared term. Same idea. Negative 2 times x is minus 2x, putting it underneath the other linear term, the other x. And then negative 2 times 7 is negative 14. He doesn't have a like term, so I'm just sticking it at the end here. Very last step is just combining our like terms, which is just adding down the rows. Look how nice and easy this is. Minus x squared plus 5x, and then minus 14. All right, final answers, my friends. We are done. Very last piece of expressions is going to be evaluating. So for these types of expressions, I tell you what different variables equal. You just have to substitute in those values for each of your steps, and then again, following your order of operations to simplify. So if I'm saying for this first example here that C is equal to 4 and A is equal to 5, then it looks like B is equal to 3. So first thing I did was substitute everything, and now let's simplify. So if we simplify our numerator first, we end up with 9, and then 9 divided by 3 is 3. First problem done. Remember, at any point along this video, you want to go ahead and pause, try a problem on your own, right? And then hit play when you're done. This might be a good example if you want to try it on your own. For those of us that are ready, I'm going to again just substitute in as a first step. So C is 4, A is 5, B is 3, and then carry down anything else. So order of operations tells us to do what's inside the parentheses first, and inside the parentheses we have exponents and we have addition. So we're going to do the exponent first. So 5 squared is 25. 25 plus 3 is going to give us 28. Do we need the parentheses here? Not really. But just to kind of keep it all together to symbolize what the steps are that I did, I'm leaving it in there, but no, you don't need it. From here we have addition and subtraction, so I'll just do it in order from left to right. So 4 plus 28 is going to give us our 32. 32 subtract 15 is going to give us 17. All right, so final answer. We got 2 more problems down the bottom. So if you haven't gotten a chance to hit pause yet and to try some of the problems, I would recommend that you do it right now for these last 2 here. When you are ready, go ahead and hit play. So again, first step is going to be the substitution. So I'm going to put 6 in for x, 12 in for y, 4 in for z. Order of operations tells us that I'm going to do my exponents first. So 4 squared is going to give us 16, because remember it's 4 times 4, not 4 times 2. Now I have multiplication to do next. So 6 times 12 is going to give us 72. So 72 minus 16, if you need the calculators, please go ahead and do that. I'd rather you use a calculator, right, than make a silly mistake. So 72 subtract 16 is going to give us 56. And that is our final answer. Last problem for the video. Let's again substitute in 5 times x has a value of 6 plus, does anybody recall those vertical lines there? Those are those absolute value bars, which means that any answer inside of it is actually going to be positive, regardless of what it looks like. So it doesn't look like it's going to make a difference here. I'm going to do the absolute value bars first, because 12 minus 4 is 8. Absolute value of 8 is still 8. So I'm just writing the 8 down. 5 times 6 is 30. That was my multiplication. Last step, I'll do my addition. So final answer being 38. All right, so that was our video on expressions. So make sure when it comes to expressions, you know how to evaluate an expression. You also know, change my cursor, okay. You also, besides evaluating, you know how to use your distributive property, your double distributive property, right? You can do it multiple times, as in the second example there. And then the first ones is just remembering your order of operations and being able to combine your like terms. All right. Thank you so much for watching.